Hi, for this video what I'm going to do is show you how to run the two-sample z-test for the difference between means in your TI-Nspire graphing calculator. I do also want to go through all the components of a well-run hypothesis test, starting with the conditions, setting up the null and the alternative hypothesis, running the actual tests, coming to our conclusion, and interpreting the conclusion. So let's get started. A guidance counselor claims that the students in a college prep program have a higher mean ACT score than the students in the general program. 45 students who are randomly selected from the college prep program have a mean ACT score of 24.1 with a population standard deviation of 4.6. The mean ACT score of 42 randomly selected students from the general program is 20.2 with a population standard deviation of 5.2. At 5% level of significance, can you support the guidance counselor's claim? All right, so there's a couple things in here that trigger that I'm going to use the two-sample z-test. The first one is the fact that it mentions the word mean, and so whenever the word mean is triggered, then that should trigger z-test or t-test. Okay. The other thing is we know that we have two samples because we're comparing two groups. So we're comparing those in the college prep program with those in the general program. Okay. So when you're going through, there's a couple things that you need to have for your conditions. And there are also some conditions that are specific to certain textbooks. So if some of the conditions that I cover look different than conditions that you have in your text, just know that different textbooks present the material in different ways. Okay, so one of the things that you have to have in order to be able to run this test is you have to have independent groups. Okay, and this would satisfy that condition. Sorry, my software is freezing. Independent groups. This is the college prep and general program students. Are independent. Okay, so if you're in one group, you're not going to be in the other group. All right. The next one that we have is that you want to have both samples are random. So it does say that they were randomly selected, okay, for both of the groups. Okay, the next one is in order for the central limit theorem to kick in order for you to end up with that bell-shaped curve, both in 1 and in 2 have to be greater than or equal to 30. So you want to ask yourself, and the answer to this would be yes, in 1 equals 45, and in 2 is equal to 42. Okay, so in 1 would be the number in the first group that we're working with, which is the college prep program, and in 2 would be the size of the second sample. Okay, and then the last one that differentiates between whether you use a z-test or whether you use a two-sample t-test is whether you know the population standard deviation or the sample standard deviation. Okay, since the population standard deviations are both known, that means that we would use the two-sample z-test. So both population standard deviations which are sigma 1 and sigma 2 are known. Okay. All right, so since all of the conditions are met, we can use a 2-sample z-test. Okay, so a 2-sample z-test tells us the difference between the two things. Okay, or sorry, test the difference between two different samples. So our next step, since we've verified that we can use a 2-sample z-test, is we have to determine the null in the alternative. Remember, the null hypothesis always has to contain equality. The alternative always has to contain an inequality statement. Okay, so if you're doing this symbolically, it is important to establish what your symbols are. So I'm going to use mu1 for the population of college prep program students and mu2 to be the mean of the general program, the population. Okay. All right, for setting up the null and the alternative hypotheses, what you're going to want to do is look for the claim. The claim is that the students in a college prep program have a higher mean ACT score than the students in the general program. Okay, so mathematically what that's saying is that mu1 is greater than mu2. And so since we have an inequality statement, since we have something where it's greater than, we have mu1 is greater than mu2, so this would be our claim. The null hypothesis would then be the complement of that. Mu1 is less than or equal to mu2, okay, where mu1 is the mean, and this is really the population mean of the college prep students. And mu2 is the population mean of the general students. Okay, so it's really important that anyone looking at this knows what symbols you're using for which one, because you could reverse this and say that mu2 is less than mu1, or if you switched your groups around. So it's really important to understand what the mu1 and the mu2 represent. All right, so let's write down all of our important information that we need for our formula. So the important information that we need is we need the size of our samples. We need the sample mean for each group, and we need the population standard deviation for each group. And all of this can be found above. Okay, remember we already talked about N1 and N2, okay, but we need to know this would be our X bar 1. And this would be our X bar 2. And our sigma 1 would be 4.6. And our sigma 2 would be the 5.2. We also need to know our level of significance, which is 5%. So this is going to give us our alpha level. Okay, so those are the things that we need to know in order to run the test. Okay, so I have them down on my paper. N1 is going to be 45. X bar 1 is going to be 24.1, and sigma 1 is 4.6. The second group is going to be 42, X bar 2 is 20.2, and sigma 2 is 5.2, which I just got from the problem. Okay, and we also decided that, or determined that our alpha level was 0.05 because 5% as a decimal is 0.05. So this is our threshold for deciding whether or not we are going to reject or fail to reject. And I am having some technical difficulties. My technology does not want to keep up with me today. All right, so our model, when I do shade it, we are going to shade to the right. I'm going to show you in your calculator how to draw this out so that you can see it in your calculator. To do that, to be able to see this, we're going to have to do it in a spreadsheet screen. Okay, depending upon your teacher or professor, they may require you to show out the work for the formula. So if they do, the formula is x bar 1 minus x bar 2. I know that there's different requirements for different courses. Some professors don't require you, or teachers don't require you to show out the work, and then other professors or teachers do. So just in case you need to know how to show the work out, I am giving you everything that goes into the entire process, which I know is very lengthy. Okay, so we would just plug in all of these values, and then we will let the calculator do all the calculations for us. Okay, x bar 1 is 24.1 minus 20.2, which is our x bar 2. This part right here ends up being 0 because we're starting with the fact that there is no difference. So we're starting with right here that if I rewrote this part as mu1 minus mu2 less than or equal to 0, the 0 came from this part over here. So the only time this would be a different number is if you were saying that it's less than 1, or if it's equal to 1 or equal to 2 or something like that. Okay, otherwise you would just put in a 0. All right, so our sigma 1 is 4.6 divided by 45 plus 5.2 divided by our sample of 42. Okay, so like I said, I'm going to go into the calculator to get our z, and I'm also going to show you the picture in there, and then we're also going to get our p-value. And our p-value, remember, is that this is our probability of getting these results if this were to happen just by chance alone. So remember, the outcomes are either going to have happened because of chance alone, or that there really is a difference between the two. Okay, so I'm going to go ahead and run this in a spreadsheet screen just so that I can show you how to draw out the results. It's easier to get all of the information that you need from a calculator screen, but if you want the calculator to draw it for you, you do have to do it in the spreadsheet screen of this calculator. So what we're going to do is we're going to select menu and option for statistics, and then it's going to ask you a couple different things, and we want the stat tests. Okay, remember that we determined that this was a 2-sample z-test, so we're going to choose option 3. And it's going to ask you, do you have the data or do you have the stats? We have the stats because we don't have anything to plug into the list. We just have the information given to us. We were given the sample statistics, the sample mean, and the population standard deviation. Okay, so the first thing they're going to ask for is sigma 1, which remember was 4.6. Okay. The next thing that they're going to ask for is sigma 2, which is 5.2. So make sure that you're plugging in the right things in the right places, or you will get the wrong results. Okay, and I have all of this written down, but I'm just getting this from the previous slide, so the 20.2. And then our sample size was 42. And then it's going to ask you, what is your alternative hypothesis? Okay, so we would select the one that matches this, which our alternative hypothesis was that the mean of the first population, those in the college prep program, is greater than the mean of those in the general program. Okay, all right. So after we select this, we can go down a little bit further and we can select this box right here to draw or shade your p-value so you can actually see what it looks like. When you do this, it's going to do it as a split screen, so I'm going to show you how to separate it. So we're going to click OK. And it will give you the drawing over here. If you want to see it more clearly, it does show us that our z is 3.695 and our p-value is 0.001. If you want to see it better, you can hit Control and up, and then when you click on this, Control and up, and Control and menu, it will allow you to ungroup. So then you can see just the picture by itself. So you can see it a little more clearly. On this, if you notice, it's going 1, 2, 3.69 is more than 3 standard deviations away. So the window doesn't even go out that far, which means that very, very little is being shaded, only 0.001, so it doesn't show us a really good shading because the shading is so unlikely to happen. Okay, so we ended up with our z is 3.695, and remember that anything over 2 is considered an unusual. Anything over 3 standard deviations from the mean is considered extremely unusual. So it's very, very unlikely that there is not a difference between these two. This is very strong evidence for the alternative because it barely ever happens. Okay, the p-value was 0.0001. Okay, which means that we have this much up here shaded. So this would be our p-value, and it would be shaded at z equals 3.695. Okay, so we only shade a very tiny portion because it's very unlikely to happen. Now remember to make our decision rule is found by comparing our p-value to our alpha level. So we can see very clearly that 0.0001 is much less than 0.05, which means that it's very, very unlikely for this to happen by chance alone, to have this much of a difference between the two groups if there really was no difference between the two groups. So this is extremely strong evidence for the alternative hypothesis. Okay, so since the p-value is less than alpha, we reject h sub 0. So remember that you have only two options for your conclusion, and that's going to be reject the null hypothesis or fail to reject. Okay, so then we want to interpret our decision in the context of the original problem. And you always want to reference your alpha level, so we can say at 5%, okay, there is very strong evidence to support the claim that the mean ACT score for the students in the college prep program is greater than the mean ACT score for those in the general program. Okay, the interpretation is very important because this is presenting your information to somebody in a way that everybody would understand. P-values and all of the z-scores and that stuff are hard for most people to understand, so it's better to be able to put it in a way that is meaningful to anybody. Okay, and you really just recap what was said in the claim. Okay, and I do apologize for the length of this video. I know that it's a very long video. It's just because it's a really long process, and most of the time it is required that you know how to show all of the work for these types of problems. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you need me to cover, please let me know that as well.